Welcome. Thank you for coming. You're here because you want to save money on storage. AWS has a wide range of storage services, and it can be challenging to work out what the right one is for each use case. Also, interestingly, sometimes you can save money overall by spending more on storage. I'll come back to that. My name's Ed, and as a storage specialist solutions architect, I spend most of my time working with customers like you, helping to make your storage cheaper, faster, and more secure. I'll be joined today by Mike Diamond, who's going to show us some of the amazing things that the Met Office are doing with data and supply at scale, and by Arushi Garg, who actually gets to build Amazon S3 as a product manager. You're going to leave here today with some clear strategies on how you can save money on AWS storage. But first, let's talk about migrating to the cloud. Enterprise Strategy Group have a great report. Please scan the QR code and look at it in some detail. But what it shows is that customers can save 69% by migrating to AWS storage. But where do these cost savings come from? I spent many years both selling and buying on-premises storage systems. And it's a really challenging thing to get right, because you get the best cost efficiencies, the best price, by purchasing years in advance. So you need to know what your requirements are today, you need to know what projects are coming, but you also need to try and predict what that growth is going to be, potentially years into the future. And it's not just about capacity, it's also about performance, sometimes even more critically about performance, because if you run out of space or performance, it's incredibly painful. And sometimes the only way out of that situation is to purchase additional storage. So you have to over-provision. It's the only safe thing to do, but not in the cloud. Here you can provision exactly what you need and then make adjustments as those needs change. And you get to pick the right tool for the job. And we've got a wide range of storage services. So here you've got the freedom to work not only with what you've already purchased and installed, but with all of these tools. You can pick the right one depending on your application requirements, depending on your cost requirements and your data protection requirements. And of course, this landscape is constantly changing. So it's important to revisit decisions, even if you're an experienced AWS customer. So these storage options serve as the source for putting your data to work, whether this is machine learning or analytics, or applications like rendering and visualization. And many of these make use of our multiple availability zones for built-in high availability. We've also got a range of data protection options like AWS Backup, Elastic Disaster Recovery, and S3's Object Lock to ensure your data's safe and, more importantly, recoverable. Now, we're not going to go into all of these services today, but we're going to focus in on recent changes and how you can narrow down your choices. And we're going to start with Elastic Block Storage. So why start here? Well, because block storage is foundational to pretty much everything you do, because pretty much all compute requires some block storage. But I'm going to make this easy. There's really only two volume types you need to be thinking about. General purpose SSD volumes provide sufficient performance for most use cases. GP3 volumes are 20% cheaper than GP2 volumes. So that's a really simple win to decrease your costs. You can also scale their performance up to 16,000 IOPS and a gigabyte per second of throughput, which is pretty big numbers. But if those numbers aren't big enough, that's when you need to look at our provisioned IOPS volumes. If you want really consistent sub-millisecond latency, incredibly high durability, 100 times the durability of GP3, 250,000 IOPS, 4 gigabytes per second of throughput, IO2 Block Express is the answer. Now, when we introduced IO2 Block Express, it was only for certain instance types. And at reInvent last year, we announced that it's now available across all Nitro-enabled instance types. So any modern compute that you've got can now use IO2 Express volumes. And these are the same price as IO1 volumes. If your performance requirements are far lower, or you've got streams of data, you can make use of our lower cost hard disk-based volume types. The real value here comes with the flexibility that elastic volumes provide, because you're free to make changes to them on the fly without disrupting your applications. You can increase their size, you can increase their performance, decrease their performance, and even change between volume types on the fly without disrupting your applications. So you get to provision what you need today, exactly what you need today, and adjust that as you need to, and automate those adjustments if you need to. Protecting that data is equally critical. So here we have EBS snapshots. It's important to understand that they're not like snapshots in most storage systems. Usually snapshots are within that system. EBS snapshots are an independent copy of the data, stored resiliently and durably in Amazon S3. But only the first snapshot of each volume is a full copy of that data. After that, it's just increments. So each day, if you take a snapshot, or each hour, it's only the changes from the previous hour that are being stored. So that actually can be incredibly cost efficient. If you need to keep snapshots for a long time, potentially month-end snapshots, Snapshots Archive is the answer. These are up to 75% cheaper than standard snapshots, but they come with a 90-day minimum retention requirement and longer recovery times. So these are perfect for those long-term compliance-based requirements. And of course, these can all be managed and automated and copied and made immutable with AWS backup. All right, let's switch to file storage. EFS is our original cloud-native file storage, designed for cloud-native applications. Amazon File Cache is designed for burst-to-cloud applications. And in the middle, we've got FSX, File System X. This is where we've taken a file system that is commonly used and automated it, built a managed service out of it. So instead of running your own Windows file server, managing the patching of that yourself, trying to build your own high availability across multiple availability zones, you can simply deploy FSX for Windows File Server and have that done for you, and continue to use the administrative tools that you're familiar with. Or you can have all of the power of NetApp ONTAP, all of its capabilities deployed in minutes. You've got the low latency of FSX for OpenZFS, and the incredibly high scale-out throughput of FSX for Lustre, all at your fingertips. And you don't just have to use one of these for all of your use cases, you can use all of them and pick the right tool. Tiering is a really key takeaway when it comes to cost optimization. FSX for Windows File Server's got two options here. You've got SSD for low latency, high performance requirements, and you've got hard disk drive where you've got low performance requirements. And we've also got incredibly powerful tiering in FSX for NetApp ONTAP. Here, the tiering is automated. Data's written into SSD, that's where you get the performance. But what happens is individual blocks of data, not the files themselves, but the deduplicated compressed blocks underneath those, if they haven't been accessed for a period of time, they tear down into capacity pool, which is unlimited in scale, fully elastic. And you get to define per volume what you want that policy to be, whether it tiers at all, how quickly it tiers. So you've got full control. Moving to Elastic File System. This is our original cloud-native file storage. If you haven't looked at this recently, it's really worth taking a fresh look. In just the last year, we've increased the performance 7-fold. You can get 250,000 read operations a second out of EFS now, 20 gigabytes per second of throughput. These are incredible numbers. To make use of that performance, you need to understand about EFS throughput modes. There's 3 of these available now. Originally, we only had bursting throughput. Bursting throughput is where the amount of performance as a baseline that you have for your file system depends how much data it's got in it. And you can burst above that for a period of time. But what if you need high performance all of the time? Well, then you have provision throughput. You work out what throughput you need, you provision it, and the file system always has that level of performance. Great. But what if your throughput requirements change? What if you need high performance some of the time, but not all of the time? It's also not very elastic, is it, provisioning your throughput? So we've released elastic throughput. This is now the default on all new file systems. To get the performance numbers from the previous slide, you need to be running elastic throughput mode. Here you're simply paying per gigabyte transferred. You don't have to define anything, and you get all the performance all of the time. And it also enables our new EFS archive class. So there's now 3 tiers of storage within EFS. You've got standard for all the performance with the associated cost. For files that haven't been read recently, you can configure a policy, say maybe after 30 days, those files move down into infrequent access. Infrequent access, we reduced the price by 36% at reInvent last year. And you can see the low cost of EFS archive class. If you want, you can have your policy automatically promote objects back again, or files back again. So when you access a file, it's moved back up into the standard class. So we've been talking about file systems. And it's important to understand that S3 isn't a file system. It doesn't let you do things that file systems do. It doesn't let you edit a file. It doesn't let you rename a file or rename a folder. There's no such thing as a folder in general purpose buckets. So despite this, we see an increasing need to access objects in S3 as though they are files, because there's lots of tooling, particularly in the machine learning space, in the high performance computing space, that need to access files. They don't understand S3 natively. So one of the things you can do here is make use of FSX for Lustre. It has a very cool feature that Mike will touch on in a bit called data repository associations. And here you can present S3 through FSX for Lustre, turning it into a fully POSIX compliant file system. So things like renames and edits all work because FSX for Lustre is looking after that and sending the data back into S3 afterwards. It can also act as a high-performance buffer in between S3 and your compute, giving you incredibly high performance. And we recently introduced the ability to adjust that performance after deployment. So you don't just fix how fast you want your file system to be when you deploy it, you can make changes to that later. Because sometimes there's a gap between planning and reality. This isn't the only way to access S3 objects as though they are files. Mount Point for Amazon S3 is an awesome new file client for all Linux operating systems. It's free, it's open source, it's fully supported by AWS, and it lets you access S3 as though it's a file share mounted within a Linux instance, either on premises or in EC2. And at reInvent, we added caching support, so now it's even faster. It's really, really simple to use. You run a very simple command, mount my bucket in this path. And I can run more than one of these. I can mount multiple buckets in multiple paths. And you can see when I go and list the contents of my folder, there are files in it. And what's happened is the mount point has on the fly converted that into S3 operations. It's done a list operation against the prefix in S3. It's got the results back, and they are appearing to the user in the Linux console as though the files are there. So your utilities can use S3 as a file system. But bear in mind, this isn't POSIX compliant. You can't do certain things with S3. You can't rename files. You can't rename folders. You can't edit files. There's no such thing as editing. You're creating a new version. So Mount Point will not let you do those things because it's built for performance and reliability first. It will be compatible with S3 first. It will not be POSIX compliant. You can do all of that within Kubernetes using our CSI driver. And that capability The technology behind it is used in our connector for PyTorch. If you've got workflows that use PyTorch, it's really simple to swap this in and get a massive performance improvement. The thing that really blows my mind with this is using the connector for PyTorch, you can write machine learning checkpoints to S3 faster than an EC2 instance can write it to local NVMe storage. Because S3 is brilliant at high performance throughput requirements. You can drive an enormous amount of performance, huge amounts of throughput with S3. But sometimes a different kind of fast is needed. Just like sometimes a bike can outperform a truck, it entirely depends on what it is you're asking it to do. And that's why we introduced S3 Express One Zone at reInvent. This has the lowest latency of any cloud object storage, 10 times lower than S3 general purpose buckets, consistent single-digit millisecond latency. And it comes with a new kind of bucket, a directory bucket. So sometimes this lower latency is very useful. And one of the main use cases we're seeing is around things like machine learning training, particularly with images and audio. And Pinterest were one of the early adopters of this, and they saw a 40% cost saving. Now, where does that kind of a cost saving come from? Well, because most of the cost of running workloads usually isn't storage, it's usually the compute. And if you're using accelerated compute, GPUs, AWS Trainium, those cost significant amounts of money, and you're paying for the amount of time that they're running. So if you can make them run faster for less time, if you can keep that compute busy and driven and full of data, then you can reduce the time it's running, reduce the overall cost. So as you can see, cost and performance really can go hand in hand. So I'm really excited to be joined today by Mike from the Met Office, who's been instrumental in addressing their performance and cost challenges at enormous scale. But first, a little history.
Thanks, Ed. As you've just seen, data is at the heart of everything that we do at the Met Office, and products, services and customers are hungry for our data. It's never been more important to understand what's happening with the weather and the climate. We think the key to effective data supply is to optimize storage, balancing performance, availability and cost. I'm here today to tell you about our data platform, a bit about weather prediction data, and to show you some real-world examples of our storage optimization. Some highlights are that we have a large amount of data, that we have some complicated customer use cases, and that we optimize data storage for exploitation. Now, the Met Office value stream starts with our global observation network, collecting data on what's really happening in the atmosphere and the oceans. That data is fed to our supercomputer capability for evaluation and for modeling, to produce predictions about the future. Our focus today is on that AWS data platform responsible for the data supply of this output, which later helps power the production of products and services. The data platform consumes supercomputer output and powers additional processing to provide useful access to data. We have implemented a range of data supply engineering techniques and storage optimizations on AWS solutions such as S3, EFS, and FSx for Lustre. Zooming in just one more time to our AWS-based platform, Service Hub, which abstracts data consumers from the complexities of science via a set of standardized APIs, all powered by the optimized storage that we're just about to explore now. Our data platform enables bulk data provisioning, public and private customers, Met Office forecasters, and industry all to access our data. So you've had an intro into our data platform. Now we're going to have a look at the data. So what goes into this data platform, what do we do to it, and how do we get it out again? It wouldn't be a Met Office presentation if I didn't have a slide on our supercomputer capability, which offers incredible capacity, generating hundreds of petabytes of data. We are just entering into an exciting delivery phase of our next generation capability, increasing capacity by 6 and then by 18 times, all leading to ever increasing amounts of data for us to deal with over here in data supply. The first thing to say about our data is that it's multi-dimensional, and every dimension is a multiplier on the amount of storage that's needed. So if you think about that just for a moment, that explains how we quickly reach terabytes of data a day. There are hundreds of forecast parameters, things like temperature and wind speed, which are all expressed over this 6-dimensional data array, designed to meet a range of customer needs. Another thing to say about our data is that there's always a new forecast from our busy supercomputer, and that data is short-lived, in so much as the latest forecast is never current for more than an hour. Let's now go into some real-world examples to show how we are optimizing AWS storage technology. Our data platform's bulk data supply, or our object service, has 2 offerings. Our forecast store, intended for those looking to maintain their own regularly updating data stores for further processing, and the other is a forecast archive, intended for projects like open data, and more of that at the end. So both the forecast store and the archive are powered by S3, but they're using different storage classes. The forecast store is frequently accessed and is short-lived. So for cost optimization, we use S3 standard class. The forecast archive, on the other hand, is accessed via planned activity. And so S3 Glacier Deep Archive is perfect, offering excellent value for long-term storage of seldom accessed data. Just to explain the customer journey for accessing this forecast store, first they subscribe to data topics for data they're interested in that we offer. They receive notification messages when we have a new forecast available, and then the final step in the retrieval of their data is a simple data download from S3. In our second example, we are both the customer and a publisher of data back to that Amazon S3 object service that we've just looked at. This time, we need to run scientific algorithms which are expecting a file system. The next 2 slides are all about how we choose the appropriate storage technology to enable the scientific algorithms to first access that data, and then once they're finished, put the data back to where it needs to be for data supply. And we're choosing technologies such as S3 or FSX for Lustre or EFS. So firstly, how do these scientific algorithms access data? Remembering they need to access data via a file system. The 2 things we've explored so far are the use of mount point for Amazon S3 that Ed introduced a moment ago, to reference the S3 objects as a file system. And secondly, we explored the use of Amazon FSX for Lustre with a data repository association, or DRA, that links that file system back to S3 buckets, plus provides lots of amazing cache. Now, mount point for Amazon S3 performed amazingly during testing, but because of our compute setup, it's not compatible. So for now, our current direction is to explore Amazon FSX for Lustre while we finish our benchmarking and understand the performance, characteristics, and I suppose the cost. The second half of that challenge is when the algorithms have finished, how do they post the data back to a file system? The first thing we explored was using EFS configured with elastic throughput mode. And the second, again, was Amazon FSx for Lustre with a DRA. Our current direction is to pursue Amazon FSx for Lustre because it gives us a huge advantage that it seamlessly pushes the data back to S3 and makes the onward data supply journey so much simpler. So we've already explored how we facilitate data supply of forecast objects to large-scale data consumers who can handle it, or handle it via their marketplaces. But with ever-increasing data volumes, one of our focus areas is on a more contextualized data offering, where consumers can take just what they want when they need it, to assist with data gravity. This is the mission of our third and last example, which is looking at how we perform data engineering on top of Amazon S3, optimizing access to our data to meet the needs of our data consumers. Our contextualized, just-in-time data consumers want data from different geospatial domains and areas on different query patterns and shapes, and sometimes even interpolated responses for a location where we didn't calculate a forecast. They want all of this from the huge and constantly updating data store to power the customer experience, all with sub-second latency. So how? We achieve this with a data engineering solution that firstly subscribes to the forecast store that we explored in the first two examples. It uses AWS Lambda to chunk and index the data into optimized S3 objects, and lastly, uses AWS Compute to expose a set of APIs to power products and services. And what does all this mean? This data supply technology currently chunks 12 terabytes of forecast data a day, making that new data available to our customers in under 2 minutes. The result of this effort is that these data supply APIs in the data platform can offer sub-second latency to complicated customer queries. As an example, the data APIs can fulfill customer requests sub-second for the one that's on the screen, accessing megabytes of data to answer that query rather than gigabytes, or even terabytes of standard forecast output. All of this while leveraging the durability, scalability, and cost efficiency of S3. In the future, we plan to explore how cloud-native technologies can help simplify what I've just shown you, and how our multi-dimensional data, and also please keep an eye out for Met Office Open Data on ASDI, Amazon's Sustainable Data Initiative. Thanks so much for listening. Back to you, Ed.
Thank you, Mike. It's really insightful to understand how the Met Office are making use of data and supply at scale, really getting the best value from their data. S3 cost optimization is something we spend an enormous amount of time working with our customers on, so I'm delighted to introduce Arushi to talk about how to get the best value from object storage.
Thanks, Ed, and thank you, Mike, for showing us a real-world example of how you can use Amazon S3 and how you can optimize costs there. Hi, everyone. I'm here to talk about how you can best optimize your usage of Amazon S3 in order to save cost. Now, choosing the right storage class is one of the most crucial decisions that you will take in order to cost optimize your usage. And why is that so? Because each of the storage classes is designed to be optimized for a different kind of workload. But remember one thing, that I am not mentioning here the S3 Express 1 zone storage class, which was the newest storage class that we launched last year that my colleague Ed has already touched upon. These are the storage classes that you get with general purpose buckets. But also remember that storage classes are actually an object level construct, which means that even within the same bucket, you can have multiple objects belonging to different storage classes. So with that in mind, let's move ahead and talk about the first storage class that you can see here on the leftmost side of the screen, which is S3 Intelligent Tiering. Now, if you do not use S3 Intelligent Tiering, let me tell you one thing. It is probably the single best way for you to save money on your S3 storage costs. I'll come back to it soon, but let's also focus on the next storage class, which is S3 Standard. Now, if you have a use case similar to Mike, where you're constantly accessing data, and it's short-lived in the storage class, you should use S3 Standard. S3 Standard is designed for data that is constantly accessed. Now, what does that mean? It means that it costs slightly higher to store data in S3 Standard, but there is no retrieval fees, no minimum billable object size, no minimum retention period, and the request costs are the lowest across all storage classes. I'll come back to these parameters soon. Now, as you go towards the right, you are progressively moving towards colder storage classes. What does that mean? It means that it progressively gets cheaper to store data in the colder storage classes. However, it costs slightly higher to retrieve data out of those colder storage classes. If you look at the names, whenever you see Glacier in the name, it means that it's designed to be a cold storage class, and it's designed for data that is either rarely accessed or is archived. Now, just like S3 Standard, you can see that the infrequently accessed data, the S3 one zone infrequent access, S3 Glacier instant retrieval have the similar performance. However, the S3 Glacier flexible retrieval and Glacier deep archive are the asynchronous storage classes, which means that retrieving data out of these storage classes is a two-step process. So it can take up to minutes or even up to hours to retrieve data out of them. Now, how do you select the right storage class for your workload? There are a couple of parameters that you can look at. The first of them is the access frequency. How frequently does your application need to read data out of the storage? Because you want to balance the lower storage cost of the colder storage classes and the higher cost it is to retrieve data out of those colder storage classes. The second one is retention period. How long does your data stay in the storage class before it is moved or deleted? And the third is retrieval time. How long can your application wait when it's trying to access data out of the storage class? For example, it costs 75% lesser to store data in Glacier Deep Archive as compared to Glacier Instant Retrieval. However, Glacier Deep Archive, as I mentioned, is one of those asynchronous storage classes, so it can take from minutes to up to hours to retrieve data out of it. So you need to figure out, can your application handle that latency? Now, maybe a lot of you are thinking that, what if I just don't know what my access patterns are? Maybe it's changing. Maybe it's unknown. And that is where your answer is S3 Intelligent Tiering. That was the storage class I showed you the first. So let's dive a little deeper into that storage class. Intelligent Tiering storage class consists of various access tiers. Intelligent Tiering automatically transitions your data from the hot tiers towards the colder tiers based on the last access date of your objects. Now, Intelligent Tiering does that automatically, and there is no charge on the transition of your data. So this transition occurs at object level, which means the objects always start in the frequent access tier. And if it's not accessed for 30 days, it's moved to infrequent access tier. For 60 days, it moves to archive instant access tier. There are also two optional access tiers called as archive access tier and deep archive access tier. If you want, you can opt into them, but you don't have to. By default, if your data is not accessed for 90 days, it goes to archive access tier, and then to 180 days to deep archive access tiers. But you do have some flexibility in selecting the number of days for the last 2 access tiers. Now, as I mentioned, there is no charge for the transition of data. However, there is a small monitoring fee with S3 intelligent tiering, and that is how we cover the cost of constantly monitoring your data and automating the transition process. Now, remember that the first 3 access tiers, frequent access tier, infrequent access tier, and the archive instant access tier, have the same latency, the same performance as S3 standard. And the archive access tier and the deep archive access tier have the performance same as Glacier Flexible Retrieval and Glacier Deep Archive, respectively. Since the launch of S3 intelligent tiering, our customers have told us that they have saved more than $2 billion. Now, that is a really exciting number for us and really encouraging news for us, as we hear that our customers take this money and use it in their business instead of having to manage their own storage infrastructure. Now, I already talked about the pattern where your access pattern for your workload is unknown or it's changing. But it's possible that you have an access pattern when you know which data is going to move, when it's going to move, and where it's going to move. So it means you can make more purposeful decisions about your data. And that is where you should be using S3 lifecycle policies. Now, these are the rules that S3 applies on your data to a group of objects, basically. There are 2 types of actions that S3 takes on your data. The first one is a transition action, which moves your data to a cold or storage class. And the other one is an expiration action, which basically deletes your data. Lifecycle policies are triggered based on the age of your data as compared to the last access date. That was what intelligent tiering did. So both of them are completely different things, and that is why they're used for different kinds of access patterns. With lifecycle policies, you do have to pay for the transition of your data. And the pay for the transitioning depends on which storage class you're transitioning to. So as you progressively move towards the colder storage classes, the transition charge will increase. Now, this transition charge is per object. So keep in mind that you are going to pay per object and not based on the size of the objects. I think it's pretty easy to understand here that this means that you need to consider what object size you want to maintain while you're transitioning. Bigger objects will be better when you're transitioning to colder storage classes because you're paying based on the number of objects that are transitioning. There are also filters that can help you make better decisions and use lifecycle policies more efficiently. For example, you can establish lifecycle rules based on object prefixes, object tags, and even object size. For example, only transition data over a particular object size. Or even transition based on object versioning. Only transition data that is older than a current version so that you can save on storage. Now focus on object size here for a bit. I think this graph summarizes really well how object size and the cost that you're paying for transitioning are related to each other. As I mentioned, you're paying per object and not the size of the object. So make sure that you think about compacting your data into larger objects when you're using lifecycle policies to transition. Illumina is one of our great customers, and only after 3 months of using S3 intelligent tiering and lifecycle policies, they were able to reduce their storage costs by 60%, also transitioning to 89% carbon reduction. These are really impactful results, and I will really encourage you to look at both of these tools. Now, you cannot change what you cannot see. So let's shift gears and try to understand how you can derive insights out of the data that you store in S3 to make better data-driven decisions. Amazon S3 Storage Lens is the first stop that we recommend our customers to use to get an organizational view of their data. But once you have determined a particular bucket of interest, we have a lot of other tools to help you make better decisions. For example, you can use CloudWatch metrics for Amazon S3 to monitor your data and even set alarms based on the thresholds of your choice. Now, you already figured out a bucket of your interest by using Amazon S3 Lens, but it's possible that you want more granular data, more granular insights at the object level. So you can use Amazon S3 Inventory that gives you object level metadata. And then you also have Amazon S3 Server Access Logs that gives you detailed request logging. With S3 Storage Lens, it helps you not just to optimize your cost, but also gives you options on how to improve data protection, access control, and even performance. It helps you monitor your entire S3 footprint and take better data-driven decisions. So if you're not using S3 Storage Lens, I would really recommend you do that. And you can even get started by scanning the QR code here or visiting this URL to get access to a hands-on lab to use S3 Storage Lens. We recommend everyone to use it. Because it has 28 free metrics that anyone can get access to get instant visibility into your storage footprint. For example, you can figure out that are you actually using any lower cost S3 storage class that you should be using? However, if you want more insights into your data, you can always upgrade and pay for the advanced metrics that we have. There are 35 advanced metrics that we provide our customers. For example, you can get a longer history of your data, and you can get a better trend analysis by paying for the advanced metrics. Research has also shown that there are a lot of customers who have actually saved 6 times more than what they have paid for advanced metrics. There are also drill-down dimensions available with S3 Storage Lens. For example, you can start at an organizational view of your data, and you can drill down into account level, regional level data, and all the way up to prefix level data. And as you can see, prefix level data is available with the advanced metrics. Last year, we also launched S3 Storage Lens Groups. Now, Groups is a part, again, of S3 Storage Lens Advanced Metrics. It allows you to customize your aggregation level of the metrics that you're trying to understand. So for example, you can choose to aggregate metrics based on object tags, object size, file extensions, and even prefixes. For example, if you aggregate based on file extensions, you can try to figure out which types of data are stored in your S3 storage, and that can help you understand what type of file extensions you should be optimizing for. Now, here is something really cool that you can do with Storage Lens when you use advanced metrics. There are 3 types of dimensions that we have here. So bear with me for a minute. On the x-axis, we have the count of objects. So as you go towards the right, it means that the object count in a bucket is increasing. The bucket has more number of objects. On the y-axis, we have retrieval rate. So as you go further up, it means that the bucket has data that is very frequently accessed. And the size of the bubble means the volume of data. Each bubble is representing 1 bucket. So bigger the bubble, it means more the data in your bucket. So now focus on this particular highlighted bucket. It has a lower retrieval rate. It means the data is not accessed much, a lot of data because it's a huge bubble, and the object count is also lower. This is an interesting bucket. You can probably look at it and use lifecycle policies to transition the data into a colder storage class, because the data is definitely not accessed much, and because the object count is lower, you're not paying a lot on the transition cost. Now, Upstocks is one of our customers who is a leading Indian discount broker and provides investment opportunities to more than 11 million customers. Now, Upstocks use S3 Storage Lens, advanced metrics, in conjunction with some other AWS services, and they were able to reduce the storage cost by 93%. That was a saving of approximately $1 million. Pretty impressive. So I'll now hand it back to Ed to wrap it up, and I hope I was able to make you understand how you can optimize your S3 storage footprint. Thank you.
Thank you. Thank you, Arushi. All right, let's quickly wrap up with some best practices. And for even more information, please scan the QR code. Okay, first off, if you're using GP2 or IO1 volumes, upgrade those, get that done. It's a really simple process, and you can save some money. If you're not making use of our managed file systems, then you should be. You're doing your own patching, you're doing your own management of high availability, you can get rid of all of that overhead. If you've got a really good understanding of your Amazon S3 access patterns, you've got use cases like Mike's where that's really well understood, make use of our storage classes, make use of lifecycle rules to move the data between those storage classes. And if you don't, S3 intelligent tiering will automatically optimize it for you. It's important to understand your object sizes because some costs are per object. And S3 storage lens, if you're not using storage lens today, you should be. Make use of the free metrics, but also have a look at what the advanced metrics can give you as well. You can get really good insights into what's going on in your buckets, how busy they are, and also those object sizes. And that will allow you to make better data-driven decisions and save money. You've probably already seen this slide today. Don't forget you can get 7 days free trial of Skill Builder to learn even more. I hope you've learned today some simple tips that you can use to save money on your AWS storage. Please fill out the survey. If you haven't favorited this session in the app, be aware that it won't come up and prompt you for the survey, so you need to scan the QR code that's on the screen. We will read all of your feedback. If you've got any questions, we'll be here for a few minutes, and then we'll be at the storage booth in the AWS Village. It's under that big pink cube. Thank you very much.